I want you to do something. Open a new tab. Go to your cloud provider's service level agreement, the SLA. It doesn't matter which provider. Find the SLA for whatever compute service you use most. EC2, virtual machines, GKE. Download it or open it in the browser. Now search the document for the word isolated. In most cases, you won't find it. Not once. The document that legally defines what your provider commits to delivering. The document that governs what happens if something goes wrong and you want compensation, almost never mentions isolation at all. Now search for security. You might find a line or two. Something along the lines of, the provider is responsible for the security of the cloud. You are responsible for the security in the cloud. That sentence, so short, so clean, so easy to read past, is doing an enormous amount of work. And most engineers have never stopped to think carefully about what it actually means. That's what this video is about. Let's be precise about what a cloud SLA is and isn't. An SLA, a service level agreement, is a contractual commitment about a measurable property of a service. In cloud computing, the property that SLAs almost universally cover is availability, uptime, the percentage of time that a given service will be accessible and functioning. AWS commits to 99.99% monthly uptime for EC2 in a multi-AZ configuration. Azure commits to 99.9% for a single virtual machine with premium storage. Google commits to similar figures for their compute offerings. These are real, legally binding commitments. If the service falls below those thresholds, you are entitled to service credits. Notice what is being measured: availability. The service was up, or it wasn't. That's it. The SLA says nothing about whether your data was readable by another tenant. It says nothing about whether a side-channel attack was theoretically possible. It says nothing about whether your network boundary was permeable in a way you didn't anticipate. None of those things affect the uptime percentage. None of them trigger a service credit. None of them are, in the strict contractual sense, the provider's problem. This isn't deception. It's the honest and accurate scope of what an SLA is designed to cover. But it means that when an engineer says, "I'm covered by the SLA," and they're thinking about security, they're misreading the document entirely. Every major cloud provider publishes something called a shared responsibility model. It's usually presented as a diagram, a stack, which should feel familiar by now, with a line drawn horizontally through it. Above the line, your responsibility. Below the line, the provider's responsibility. AWS describes it this way. They are responsible for the security of the cloud, the physical infrastructure, the hardware, the hypervisor software. You are responsible for the security in the cloud, your operating systems, your applications, your data, your access controls. On the surface, this seems reasonable. And in practice, for most purposes, it is. But let's look at exactly where that line is drawn. The provider owns everything below the hypervisor, the network backbone. You own everything above it: your virtual machines, your containers, your application code, your data, and the hypervisor itself, the exact boundary layer we spent so much time on in the last video, the layer that enforces isolation between tenants, sits on the provider's side of the line. This means that the correctness, the security, and the integrity of the primary isolation mechanism is entirely the provider's responsibility, and entirely outside your ability to inspect or verify. Now, and this is important, that trust is generally well-founded. AWS, Azure, and Google invest enormous engineering resources in hypervisor security. They run bug bounty programs. They patch aggressively. The hypervisors are not where most real-world security incidents originate, but generally well-founded trust in a system you cannot inspect is a very different thing from a contractual guarantee you can hold someone to. The SLA doesn't cover it. The shared responsibility model explicitly puts it outside your control. And yet, almost every engineer's mental model of cloud security treats it as a solved problem. Let's zoom in on a specific piece of language that appears constantly in cloud documentation, because it's one of the most consequential phrases in the industry: logically isolated. AWS describes a VPC as a logically isolated section of the AWS cloud. Azure uses similar language for virtual networks. The word logical is doing significant work in that sentence, and it's worth unpacking exactly what it means. Logical isolation means the boundary is enforced by software, by logic, rather than by physical separation. Your VPC traffic doesn't leak into another customer's VPC because routing rules prevent it, not because the packets travel on physically separate cables. This is a genuine and meaningful guarantee. The routing rules work. Traffic is controlled. Your VPC really is isolated from other customers' VPCs in any practical operational sense. But logical also implicitly acknowledges what it is not. It is not physical isolation. It is not isolation that holds regardless of what happens at the hardware or firmware layer. It is isolation that is contingent on the correctness of the software enforcing it. When Spectre and Meltdown were disclosed, AWS's VPCs were still logically isolated. That sentence remained completely true. And yet the attack bypassed every element of that logical isolation because it operated at a physical layer, the CPU cache, that the logical boundary simply didn't reach. The language was accurate. The implication most engineers drew from it was not. This pattern repeats throughout cloud documentation if you read it carefully. Providers choose their words with considerable precision. Logically isolated, not isolated. We are responsible for the security of the cloud, not we guarantee your workload is secure. Designed to prevent, not prevents. Each of these phrasings is accurate. Each of them is also somewhat less than what a casual reading might suggest. I want to be careful here, because I'm not arguing that your cloud provider is being deceptive, or that the cloud is less secure than alternatives. The cloud, operated correctly, is extraordinarily secure. The hypervisors that AWS and Google run are almost certainly more hardened than the bare metal infrastructure most organizations could afford to build themselves. The physical security of their data centers exceeds what most enterprises manage. The engineering effort that goes into patching and hardening these systems is genuinely impressive. What I'm arguing is something more specific, that there is a gap between the mental model most engineers carry. My workload is isolated, it says so in the docs, and the precise, carefully bounded commitment those words actually make. That gap matters most not when everything is working, but when something breaks, when there's an incident and you need to understand your actual exposure. When you're designing a system that handles genuinely sensitive data and you need to decide whether additional controls are warranted. When you're explaining a risk to a stakeholder who asks you to be specific about what the provider has and hasn't guaranteed. In those moments, the difference between the docs said isolated and the docs said logically isolated at the network layer, with the provider responsible for the hypervisor layer and no contractual SLA covering security properties, is enormous. One of those answers lets you think clearly, the other doesn't.